Hello, learners! Welcome to the next lesson in our machine learning project, where we delve into the realm of regression analysis and the essential task of dataset splitting for model development. In this session, we aim to understand and implement the concept of finding the best fit line for two variables using the Lmplot function, a powerful tool that visually showcases the relationship between these variables. This graphical representation will enable us to grasp how these variables correlate and aid us in preparing for further model development. Our primary objective here is to comprehend the essence of linear regression and how it helps us model relationships between variables. By employing Lmplot function, we'll witness firsthand how to identify trends and patterns within our data, crucial for creating effective predictive models. Furthermore, we'll delve into the implementation of Scikit-learn, a remarkable library in Python, to split our dataset into three distinct portions: training, validation, and test datasets. This segmentation is pivotal in ensuring that our model is robust, accurate, and generalizable to unseen data. Through this process, we strive to strike a balance between training our model on sufficient data and validating its performance on unseen samples. As a data scientist, it's imperative to comprehend not just the theoretical underpinnings but also the practical implementation of these concepts. The skills we develop here will serve as a cornerstone for building predictive models that drive insights and decision-making in real-world scenarios. Linear regression is a statistical method used to model the relationship between a dependent variable, often denoted as y, and one or more independent variables, often denoted as x. Firstly, let us discuss the Lmplot function, which is used to find the best fit line in a dataset. The Lmplot function in Seaborn is designed specifically to create a scatter plot with a linear regression line fitted to the data. This is extremely valuable when we want to explore the relationship between two variables and understand if there's a linear trend or correlation between them. The Lmplot function visualizes this relationship by plotting the data points as a scatter plot and fitting a straight line that best represents the overall trend observed in the data. The purpose of this interface is to make fitting regression models across conditional subsets of a dataset simple and convenient. To plot the linear model plot, we will write the following line of code: sns.lmplot. This function is part of Seaborn, and it's used to create a scatter plot with a linear regression line fit to the data. It's particularly useful for visualizing the relationship between two variables and understanding if there's a linear trend between them. Inside brackets, x equals length of membership. This specifies that the variable on the x-axis of our plot will be length of membership. Y equals yearly amount spent. Here, we're specifying that the variable on the y-axis of our plot will be yearly amount spent. Data equals df. We're using the data frame named df to provide the data for our plot. This data frame contains our dataset that contains the columns length of membership and yearly amount spent, among others. Scatter underscore KWS equals alpha 0.3. This parameter allows us to adjust the appearance of the scatter plot by passing a dictionary of scatter plot specific keyword arguments. In this case, we're setting the alpha parameter to 0.3, which will make the point somewhat transparent, aiding in visualizing density and overlapping data points. In this plot, a best fit line has been formed, which fits the given scatter plot. This best fit line is created by our linear regression model plot by calculating the distance of each point from the best fit line. This distance is then squared and summed up. The best fit line is found when the sum of the squared distances from each point reaches its possible minimum value. Thus, this function will create a line that is as close as possible to each and every point on the scatter plot. For example, we need to predict the yearly amount spent by a customer that has had a membership length of 6 months. Using the regression line, we can predict that the possibility of the amount spent is somewhere between $600 to $650, approximately around $640. This value is pretty close to the actual values present in the dataset for the given length of membership. Here we understood the best fit line for two variables in the dataset. However, this linear regression model prediction can be done with more variables by adding more axes to the plot. Here, if we add a third variable, the scatter plot will be created in a three-dimensional view with x, y, and z axes. Similarly, it can be done for n dimensions. In machine learning, it's crucial to assess the performance of a model on unseen data to understand its generalization capabilities. Linear regression models include training the model with some amount of data and testing the model with other data that is not a part of the training dataset in order to test the model's accuracy. In this scenario, the dataset available to the data scientist has been provided by the retail store, which consists of 500 rows. The train-test-split function is widely used to split a dataset into two subsets, one for training the model and the other for testing its performance. To implement this, we will firstly import the train-test-split function from the model selection module within the Scikit-learn library, also called Scikit-learn. From sklearn.model_selection import train_test_split. Here's how it works. Training data. This function divides the dataset into two parts, a training set and a test set. The training set is used to train the machine learning model. It contains a portion of the original data, usually the majority, such as 70 to 80% of the data. Testing data. The test set, on the other hand, is used to evaluate the model's performance. It contains the remaining portion of the data, usually 20 to 30%. The primary purpose of splitting the data into training and testing sets is to assess how well the trained model performs on unseen data. If the model performs well on the test set, data it has never seen during training, it's an indication that the model generalizes well and can make accurate predictions on new, unseen data. Before performing the split, we will divide our dataset into two sets. First will be a set of predictive variables, namely x. We use uppercase notation for sets that consist of more than one variable. Typically in machine learning, x is used to represent the feature matrix, which contains the independent variables used to predict the target variable. X will consist of the four predictive or independent variables: average session length, time on app, time on website, and length of membership. To import the data into the set x, write x equals df, inside brackets in single quotes, average session length. We are creating a new variable x by selecting specific columns from the data frame df. To view the variable x, we can observe the variable average session length containing 500 rows as per our original dataset. X equals df, inside double brackets, average session length, time on app, time on website, length of membership. This part of the code is using double square brackets to select specific columns from the data frame df. The columns selected are average session length, time on app, time on website, and length of membership. X equals. This selected subset of columns from the data frame df is then assigned to a new variable named x. Here we can observe the subset of columns formed. Therefore, the variable x now contains a subset of columns from the original data frame df, specifically the columns related to average session length, time on app, time on website, and length of membership. In a machine learning context, this x variable could be used as the input features for training a predictive model, where these selected columns are used to predict or explain another variable, often referred to as the target or dependent variable. Similarly, we will create another variable y. In machine learning, y typically represents the target variable or the dependent variable, which is what we want to predict or analyze based on the independent variables. Y equals df. Inside brackets and single quotes, yearly amount spent. Y. The selected column from the data frame df, which contains the yearly amount spent, is now assigned to the new variable named y. Therefore, the variable y now contains the data from the yearly amount spent column in the original data frame df. In a machine learning context, this y variable is often used as the target variable, representing the output or response that a model aims to predict or analyze based on the features present in the x variable, the input features. Now that we have our predictive and target variables saved into the variable x and y respectively, we will use the train-test-split function that we imported above to split the dataset. To do this, we will create four new variables as x_train, x_test, y_train, y_test equals These are the 4 variables that we have created to save the train and test dataset of the predictive and target variables respectively. train_test_split. This function from Scikit-learn is used for splitting the dataset into training and testing subsets. It's commonly employed in machine learning workflows to assess model performance. Inside brackets, x, y, these variables represent the input features x and the target variable y. X contains the independent variables or features used to predict the target variable y. Test_size equals 0.3. This parameter specifies the proportion of the dataset that will be allocated to the test set. In this case, test size equals 0.3 means that 30% of the data will be reserved for the test set, while the remaining 70% will be used for training the model. Random_state equals 42. This parameter sets a seed for the random number generator used by the function. By setting random state equals 42, you ensure that the data split is deterministic and reproducible. Using the same random state value 42 in this case will result in the same data split each time the code is run. The function train_test_split takes the feature data x and the target variable y as inputs and divides them into 4 subsets. Let us take a look at them. x_train. This variable holds the training set of features, which comprises 70% of the original data, x. It's used to train the machine learning model. As we can see here, it has 350 rows, 70% of 500 rows for all the 4 columns. x_test. This variable contains the test set of features, representing 30% of the original data, x. That is 150 rows in this case. It's used to evaluate the model's performance on unseen data. y_train. This variable contains the corresponding training set of target values associated with the x_train data. y_test. Similarly, y_test contains the corresponding test set of target values associated with the x_test data. In summary, we have performed a split of the dataset into training and testing sets, allowing the model to be trained on one subset and evaluated on another, facilitating the assessment of the model's performance on unseen data. Thank you.